This conference will now be recorded.
Okay, so good morning, all, and welcome back to the session. And in today's session, we are going to discuss about Amazon Redshift. Amazon Redshift. Amazon Redshift. So Amazon Redshift, that is a very famous tool or service from the AWS side, and it is a data warehouse. This is a very famous service from AWS side. This is a data warehouse, DWH. This is a data warehouse. Now, what I can say, data warehouse on cloud. This is a data warehouse on cloud. Uh, the another thing which is coming in our mind is this the single warehouse data warehouse available in market. That is not true. We are having a data warehouse which are available inside the market, but Amazon Redshift is the good one or the better one from among those. What was happening with respect to the other data warehouses or traditional data warehouses? What I can say, the initial setup cost for the traditional data warehouses are very high. Okay, what I have mentioned, this is the cloud-based data warehouse. So traditional warehouse, data warehouse, traditional data warehouse. So traditional data warehouse, say on-premises data warehouse, data warehouse, like what I can say, Hive. Hive is the data warehouse only. But what is the issue with Hive? That is on premises, and if something is on premises, then the setup cost is very high. Setup cost is very high. So initial setup cost is very high. Initial setup cost is very high. Now, if we need to add certain resources to the traditional data warehouse, then that is a complicated process. Or what I can say, challenges in traditional data warehouse. So initial setup cost that was high, then scaling related issue. So scaling is nothing but if the data warehouse, you can think in this particular way, like initially we are having four machines inside the Hive cluster or Hadoop cluster where we are having Hive. Now the data has been increased and we need to have more resources. We need to have more machines. Then what we need to do, we need to add certain more machines into the cluster. So at that moment, like the complete cluster will be down and services will not be available at that moment. So scaling related issues are there, and the scaling will be the time taking process. Time taking processes. Scaling is time taking process. So while why this is time taking process, because like if the data has been increased and we need to add certain nodes onto the cluster, then we need to identify space and all a lot of things we need to consider, and we need to like proceed for the power backup and all. So and we need to proceed, we need to take the maintenance related things as well. So a lot of things will be taken into considerations once we are performing the scaling. So that is a challenging issue once we are talking about the traditional data warehouses. And traditional data warehouse, what is happening over there, like these are placed on a particular location. So if certain natural calamities are happening over there, so like say flood related issues are there, and at that moment like entire cluster is impacted because of the flood or earthquake, whatever. So the services will be down now. So what I can say, possible loss of data. So possible loss of data because of say natural calamities. Calamities or natural disaster. Okay. So natural disasters or calamities can result in loss of data. So these were the challenges in the traditional data warehouse, or what I can say, these are the challenges of on-premises solutions. If we are opting cloud, with respect to on-premises solutions, then we will be getting the benefit onto top of these. Like initial setup cost is nothing. Once we are using cloud, we just need to pay as per our usage. So these are certain benefits what are given by the cloud services, and Amazon Redshift is a cloud-based data warehouse, and it has taken care of all of these particular challenges. And now what I can say, we are able to process the data, we are able to store the data, and we are able to process the data as well. So this is having certain betterment with respect to the traditional data warehouses. But this is not a formal definition. What we have talked about, like we have talked about the cloud solutions or the on-premises solutions. What are the benefits which are given by the cloud solutions and all. But what is the formal definition for Redshift? Redshift. So this is fully managed, fully managed petabyte scale. Just focus over here. Petabyte scale, fast and scalable, fast and scalable data warehouse service on cloud, on Amazon cloud. What I can say. Okay, so fully managed. It means this is like from the user perspective, they don't need to bother. It is completely managed by AWS, and they, from the maintenance related stuff, we just need to like click and create the Redshift cluster, and entire maintenance related stuff will be done by Amazon only. Yeah. And there is no need to like set up the cluster and all on premises, so no infront cost is there, and uh, like and once we need to like the query onto top of data which we are having, so it is able to query, or we will be able to do the analysis onto the petabyte of data. Petabyte, like a huge amount of data we will be able to query from this particular data warehouse service. So petabyte scales, once we are querying the data which is stored inside the Redshift. We are having Redshift Spectrum as well, which is a component which is built, which is placed on top of Redshift, and where with the help of the Redshift Spectrum, we will be able to query the data which is placed inside the S3. So we will be able to query the data which is placed inside the S3, or Redshift itself is a cluster. We can query the data within the cluster as well. Just try to focus over here, Redshift cluster, and Redshift cluster, what we are having, different nodes are there. This is also a master and slave architecture. We will be having one master and different slave nodes. So what we are doing over here, we are moving our data and placed it inside the Redshift cluster and then query it. So that is one way of working with Redshift. Another way, what we are having data placed inside the S3. Then we are having Redshift spectrum, and then we are having Redshift. So, so this Redshift spectrum is acting as a bridge between S3 and Redshift. Now, what is happening? Once we are querying the data which is placed inside the Redshift cluster, so it is saying, say, we will be able to query petabyte of data, query petabyte of data. So once the data is placed inside the cluster, we will be able to query petabyte of data. But once the data is placed onto S3 and we are leveraging Redshift Spectrum, then we will be able to query exabyte of data. Okay, exabyte of data. So that is like the betterment which is given by S3 on the Redshift only. Redshift Spectrum is a component which is built on top of Redshift only. Yeah. Now there are certain other benefits which are given. Like if data is placed on S3 and some data is placed on uh, Redshift. Okay, so we can leverage to perform join. We can do the joining onto that particular data. Okay, so that is quite possible. Data is placed inside S3 and some data is placed on Redshift. So we will be able to perform the joining. So that data will be joined and we will be able to query on that particular data as well. Like certain one table is over here, one table is over here, and that is possible with the help of Redshift Spectrum only. So with the help of Redshift Spectrum, you will be able to join the data which is placed on S3 and Redshift. Now, formal definition is denoting this is fully managed petabyte scale. Petabyte and exabyte related stuff we are able to see over here. Like with the help of Redshift, we will be able to query and analyze or store and analyze the data. And that is huge amount of data. Fast and scalable, we have already gone through with that particular aspect. Like this is the scalable system, and if we need to add more machines, then from the user perspective there is no need to worry. Amazon is going to take or do Amazon is going to scale up or scale down these particular things. We just need to provide our wish and do certain clicks, then things will be done automatically and resource will be available. Another nodes will be available within a fraction of seconds. So this is fully managed and scalable. Horizontal scaling is quite possible. It's very easy over here. Then what I can say, fully managed petabyte scale, fast and scalable data warehouse service. So that is fine. Whatever we have seen, that is with respect to data warehouse. Data warehouse, because we have started Amazon Redshift, and warehouse as a service, or warehouse are the things which are utilized in order to process and store the data. the data. So data warehouse, data warehouse. So process and store data. Their data warehouses are utilized in order to process and store the data. Then we are having certain other terminologies as well, say database, data warehouse that we have discussed. Then we are having data lake as well. We are having a delta lake. We are having lake house as well. These are certain fancy words on delta lake, lake house, or data lake. Data warehouse, what we have already discussed. All of these particular tools are utilized in order to manage your data, in order to store, and some tools are utilized in order to process as well, like from the database, data warehouse, delta lake, lake house. We will be able to process and store the data. Data lakes are utilized in order to store the raw data only. Yeah. Data lakes for the storage perspective. Rest all the tools are utilized in order to process and store the data. So based upon our need, we just need to opt a particular tool. We are talking about data warehouse at this moment. So do you have the understanding about data warehouse, data lake, delta lake, and lake house? Or do you want me to explain? In our previous session, we have discussed about data lake, data warehouse, and data base. Delta lake and lake house, these are not discussed. Are you having the understanding about delta lake and lake
Please,
house?
please mention something related to that. I'm not having any idea.
Okay, okay. So let me mention. Database, that is nothing but uh, okay. So what I mentioned, these are used in order to store and process the data. Store and process the data. Process structured data basically. Yeah, structured data. We are talking about database, and data is organized in row and columns. We know it very well. And we are having a proper schema over here. Schema. Then SQL is utilized. SQL is used to query the data. Okay. These are ACID compliant. Okay. And where what we are having schema on writing. Schema on writing and used for OLTP. Yeah. OLTP, online transactional processing. Online transactional processing and latency is very less over here. Very less. So the database are providing very less latency, and these are certain benefits which we are having. ACID compliant, because these are ACID compliant, so because of that particular nature, these are used for OLTP related stuff. Latency is very less, and once we are going to write the data inside a particular database, then we need to first define the schema, and then we are going to write the data. Okay, so schema on writing is there. So these are the characteristics of a database. With respect to the data warehouse, what we have seen, uh, Redshift, that is a data warehouse. But what are the things over here? Now just try to think over here, like we are having the data source, and from the data source we are going to read the data. Over here, what we are doing, the ingestion is being happening, and then we are putting it inside a data storage basically. Okay, so with respect to from the certain sources, what we are doing over here, we are performing the ingestion and we are moving the data inside the data storage. The data storage can be database, then data lake, data warehouse, lake house, whatever. Okay, so it can be anything. We can have different data sources, data storage basically, not the sources. So from the data sources, what we are having raw data, and now we are putting it inside the data storage, and we can leverage these particular tools in order to store and manage that particular data. Okay, so database, what we have seen, these are used to store or to handle the structured data only, yeah. Database is going to handle structured data only. In the same fashion, what we are having data warehouse. So data warehouse are also handling handling structured data structured data. Now, structured data is handled by data warehouse. What are the other things? What about schema with respect to data warehouse? Schema is on read or write. Swati, Rahul, Rohit, Shivam,
Read.
read. Swati, Vandana, schema is read or write.
For data
Right.
lakes, sir?
Hmm?
The
What we
schema
have
will be
done, come again, schema on.
right.
Schema
Right.
is on write and data is on read.
Data on read. I didn't get what is data on read.
Store data in warehouse.
So what we have done, we were having certain files, okay, inside MySQL. Try to recall. We were having certain files in MySQL. We have leveraged Scoop, okay, in order to perform the ingestion of those particular files and put it inside the HDFS. Okay, so ingestion is happening over here. Now these particular files are there, which are placed inside the HDFS. Now what we have done, we have created Hive tables in order to read the data. Okay, Hive tables to read the data which is placed inside the HDFS. So schema on read. Are you able to recall? And Rohit, why you are confusing yourself? Huh? Data on read is nothing, right? Rohit,
Yes.
Okay, so this was the stuff what we have done, and this is happening in each and every case once we are dealing. So you can think, once you are having data which is placed inside the data warehouse. So data warehouse, for this particular data warehouse, it might be possible. uh, Let me talk. You have not gone through with Redshift, but let me give you an example of Hadoop. Inside the Hadoop, Hive is leveraging the backend storage of HDFS. The storage is HDFS only. So the data is placed inside the HDFS, but inside the Redshift, the data storage, the storage layer will be this Redshift cluster only. The data storage is available over uh, inside this particular cluster only. But the Hive was using SDFS as a storage layer. So the data is placed in terms of files over here. Data is placed in terms of files. Now what you are doing over here, you are having Hive as a data warehouse. So with the help of Hive, you are creating table based upon the data which is inside the SDFS files. So what you are doing over here, based upon the data, you are going to create a schema. Okay, schema. Why? You have already written this particular data inside the HDFS. Now you need to read the data. You need to read the data in order to perform the analysis. So you are defining the schema at that moment. Hive is leveraging HDFS as a storage layer. The data is placed inside the HDFS. Let me repeat it once again. The data is placed inside the HDFS. Now you are defining the schema in order to read the data. So schema on read, that is fine. Now the another benefit what we are having over here, it is used for, what? ETL, extract, transform and load. Extract, transform and load. So extracting the data which is placed from the sources, data source, from the data source we are extracting the data, we are transforming it over here. Transforming, during the Hive query we can do the transformation. So transforming it and then loading it. Again we will be able to load it once again. Or what you can do, you can check, you can have, say, if we are having 500 counters or 500 columns for the, we were having 500 columns. Now you want to have 50 columns only. You want to have 50 columns only. So what you can do, in your table, you just create 50 columns only in order to extract the 50 columns from that particular raw data, and you will be having the tables with respect to, you will be having those particular columns from that particular data. So extract, transform and load is the stuff which is done with the help of data warehouse. Okay, data warehouse are responsible for ETL related stuff. And if someone is asking like where you are putting the data after performing the ETL, you can directly mention we are having this particular data warehouse where we are performing the ETL related stuff. And like you can leverage a glue in order to perform this ETL, and then data will be moved to your Redshift. Okay, and over there you will be having the refined data. It will not be the laundry list. You will be having the refined data, and that will be utilized in order to further processing. What is the betterment of this? It is going to make the query performant. So if you are having data that is raw data, and you need to, or you are having the complete data, let me mention the correct word, you are having entire data. So once like it is placed inside the data lake, that is say raw data, and now you have created certain tables onto top of that, and it will depends on you, either you are moving with all records or filtered record. So data warehouse, with the help of data warehouse, you will be able to do the filtration, and it is going to make query performant. Okay, is it clear? Make query performant. Now the query will be performant because you are dealing with less amount of data. You are not working onto the complete laundry list. So the query will be performant over here. With respect to the latency, it is having more latency than database. So data warehouse is having more latency, and this is for OLTP and it is for OLAP related stuff. Online analytics processing. Analytics. So once the word OLAP will come, then you need to think that OLAP is the analytics processing. And once we are doing the analytics, so we are dealing with historical data. Okay. So once we are dealing with historical data, then we can have more, we can like remove certain records over here. We are dealing with the current data inside the databases, that is the which are acid compliant, and we are using it in banking related. You can say data processing, transactional data processing is there over here, and we can't avoid any transactions, we can't remove any transaction from this particular database, but over here we can remove certain transactions, or in order to perform the analysis and all. So those are the things what we have already discussed in our previous sessions, once like we have gone through with the differences between the analytics and transactional processing. So analytics, that is dealing on to the historical data, and data warehouse are best for like for the OLAP related stuff, and latency is more with respect to the database. Schema is on read, and these are also working on to the structured data, that is data warehouse. Now with respect to the data lake, what we are having, data lake. So data lake, just try to think over here. Now from the raw sources, from the data sources where which are having raw data, what we are going to do, we are just moving it inside the data lake. So data lake are having raw records, raw data, having raw data, and these are good for ELT operation. Deals in ELT operations. Okay, over here, what we are doing, we just extract from the source, load it, and after loading that, the transformation will come into the picture. So loading is done first over here. Inside the data lake, the loading is done first, and then we will be having the transformation related stuff, like whatever we want to do on to top of that particular data. Then we will proceed for the transformation. So it is dealing with ELT related stuff. So ETL and ELT. ETL data warehouse, ELT data lake. Another thing, uh, data available in terms of files, terms of, in form of files, what I can say, files. Okay, so inside the HDFS, inside the S3, that is nothing but the data lake only. Yeah. So data is available in terms of objects or files over there, and that is the raw data basically. That is raw data. Now you need to do the processing onto top of that. There is one advantage of data lake. Say what is happening over here. Once we are working with data warehouse, so we are performing extracting, transforming, and then loading up. After transformation, we are going to load the data. So say 500 counters were there, and we have done the transformation onto 500 counters and converted into 50 counters. So we will be having 50 counters only. Now you can think in this particular way, like these are the 50 counters or 50 columns, and based upon what we are going to calculate certain KPIs. Now the formula has been changed and we want five more counters as per new formula, which is placed, which are available inside the raw data. But we are not having raw data over here. We have done transformation and then loading. We are having 50 columns only. So there are two ways. Either like we need to do the ingestion once again in order to get the remaining five counters and then proceed for transformation and then loading, or what we can do, we can start the new process that till now we will be able to provide the data with respect to the previous 50 columns, and from today onwards, like we will do the ingestion, fresh ingestion of the new data, and then you will be having the new KPI, yeah, based upon the 55 columns. So the efforts will be more over here if there is certain change inside the calculation, or if we need to have some more data, raw data, that is not available in transformed record, so we need to perform certain more actions. That is the challenge with data warehouse. But with respect to the data lake, what is happening over here, we are performing ELT. So extract, load, and transform. So transformation is happening after loading the data. Loading is done first. So we will be having the entire raw data, and we will be working on to the entire raw data, and then we are going to do the transformation. So that particular challenge which was faced inside the data warehouse is not available inside the data lake. Okay, so that is data lake. Over here, what we are having, the data, it is having structured and unstructured data. Okay, data with different, say, formats. Okay, over here as well we are having schema on read. Okay, if we are having certain data inside the data lake and we want to read the data, then we need to perform the we need to define the schema, and then we will be able to read it. Then we can integrate it with data warehouse, integration with data warehouse. With data warehouse. So integration with data warehouse, what is the meaning of this? Like say we are having Hive, what we are doing with Hive? Okay, Hive is nothing but the data warehouse. So we can integrate it with data warehouse in order to process the data which is placed inside the data lake. Okay, so integration is possible, or like organizations are using a mechanism where they are integrating the data lake with data warehouse. So that is the stuff which is going on inside the market. This is very cost effective. Okay, so if we are talking about cost, data lakes are having least cost, then data warehouse are having more cost. Okay, and database are very costly. Yeah. Okay, so database costly, more cost, or very less cost? Okay, so with respect to the costing, this is the stuff. Okay, then the scaling, it is performing say horizontal scaling. Okay, like addition of more nodes is quite possible over here. We can add more nodes. It can be on cloud, it can be on on premises. Okay, on premises we are having say HDFS. On cloud we are having S3. Okay, so different data lakes are available inside the market. That is something about data lake. Now, Delta Lake. Is it fine? Database, data warehouse, and data lake. Any doubt
Yes.
on to others? Database, data warehouse, and data lake. Is it fine?
So, sir, only databases on it has the processing where schema is on write. For other two, it is schema on read.
Hmm.
Okay.
Try to
Yes, sir, you
think,
can
Swati.
proceed.
Try to visualize. So you are having data. You are having some data in a file. Now you need to create certain tables onto top of that. You need to create MySQL tables. So what you are doing over there? First you create the table, then load the data in that particular table from that particular file. Right? And now the data is available, the table is available. In that particular table we are having data. Now you can run the query, select star and all. So during while loading the data, we need to we need to create table, right? But what is happening in terms of Hive? The data is available in HDFS only. We are not performing the loading, right? Are you able to visualize? We have done these particular things multiple times. Are you able to visualize, Swati?
Yes, sir. Vanna, sir,
Okay.
actually.
Oh, sorry, Vandana. I thought you are Swati. Okay. So, Vandana, the thing is that probably you are not gone through with that particular aspect. It was done in our previous classes. So, we are having MySQL. So, uh, let me try to open. Let me try to show something. Okay, so okay, so this is nothing but a database. Okay, Vandana, this is a database what we are having, MySQL database. Huh? Now, this particular MySQL database is running on a machine. Huh? It is running on this particular machine. Huh? Now, what is happening over here? Like once we are having a particular database, then in order to load the data, okay, in this particular, in order to write the data in the database, what we need to do, we need to create a table. Huh? Okay, so we need to create a table over here. So what I can say, these are the databases, huh? And I can take a database, say use batch 21. Okay, show tables inside this. Okay, so these are the tables which are available in this particular data. So over here, what I'm going to do, I'm going to create a table. I'm going to create a table, and then I will
Sir,
be trying to.
before you proceed, I have a
Mm-hmm,
question.
mm-hmm.
If you go on the top, you write, you run one command, show database, and it gave you some list of the databases. Where are these
Mm-hmm.
databases stored? Is it on your system somewhere?
Yes, in this particular machine only, yeah. In my machine. Okay.
In your machine, like it is
In
online,
my
on cloud,
no, on my machine, not on cloud. Huh?
on your
This is
system, near computer.
yes. This is on my system. Huh? So I have opened this particular software, VirtualBox. Inside this, Cloudera Quick Start VM is there. Probably you have gone through with these particular sessions and Cloudera Quick Start VM. We have gone through with Hadoop and all. Huh? Is it? We have
No,
covered these
sir, I
particular.
was, yes, sir, but
Mhm.
I actually didn't attended those sessions. I joined,
Mhm.
maybe it was in the beginning, right?
Right.
Yes, sir.
So
So
over here in
MySQL,
my
I haven't
machine,
attended this. Then again, this table in Bash 21. So Bash 21, can I say it is a folder in your system?
no, this is a database. Once we are talking about database, inside the data, MySQL, that is a database basically. Okay, so you can think like we are having in the database terminology, whatever we are going to create say databases, and in the databases we are going to maintain the tables. You can think in this particular way, like we are having a directory, and in directory we are having files. You can think in this particular
Okay,
way.
okay, sir.
Okay,
Okay.
so if we are having certain databases over here, and we have like moved inside the best 21. So inside the best 21, say I'm going to create a table, create table, and say redshift. Like today we are going to cover redshift. So table redshift, and what I can give, say person, and person ID, or I can guess a student ID. Yeah? Student ID, and that is of say integer type, and student name, and what I can say varchar. Okay, Okay, now show tables. It is going to list this redshift table as well. Now try to focus, all of you try to focus over here. Let me try to run select star from redshift. Okay, it is displaying like empty set. Nothing is there. So we have created a schema. Till now nothing is there inside this particular database. In this particular file nothing is there. What I need to do, either I am having a particular file, from there I can load that particular file in this particular table, or I can insert the record. So insert record. Let me insert the record into this particular table. So insert into and say redshift and say values, and with respect to the value, what I can say, 1, and say Rohita. Okay, now I'm going to run that particular command. So we are having one record in this particular table. So what we have done, in order to write the data in this particular table, we have defined this particular schema, and this particular like definition is nothing, that is a schema definition. Okay, so describe redshift. Okay, so this is showing the schema of this particular table. Field, student ID, student name, type, integer, variable, character, null. Yes, yes, key. We have not defined a particular primary key and all. Default null. So that is nothing but a schema of this particular table which we have defined. Okay, so over here, what I want to say, inside the databases, the schema is defined on write. Like once we are going to write the data, we need to define the schema, then we will be able to read up. But it is not the case once we are working with data warehouse and data lake. Over here data is available already available over there in terms of files. Then we need to create tables
But
on the
when
top of
we
that.
call data warehouse, we say that it is structured data. That means
Mhm,
it is structured. So there should be
mhm.
already like when we are storing the data, it should be again schema on, right?
No, 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 data is already
Because
available inside
when
the.
we talk about data lake, we have
Mhm,
structured and unstructured data both. So for that,
mhm,
like if I try to understand in layman terms that
mhm,
it is not
mhm.
possible you have raw like different format of data in a stable form. But here in data warehouse, when it is structured, there should be also a table, no? No?
No, table is not there. Once we are talking, I'm having a particular file. File and table both are the different things. Okay,
Okay, okay.
so this is a file. BDF say this is a file, right? Okay, so this is a file over here. Now, if you are going to create a structure onto this, then you need to mention say this particular column is say the details. This particular column say value. Okay, details and value. You need to define detail and value. Then you are going to insert this particular record into details and value, right? So that is what you are going to create a structure onto top of this particular file,
Okay.
right?
Okay, sir.
Okay, so you are going to create a structure on top of file, and that will be a table. You can say in another word, that will be a table, and now you will be able to query onto the table, right? Okay, same thing is
Yes, sir.
happening in Spark as well. So what you are doing, you are creating a structure, you are defining, you are providing a schema onto top of this particular file, and that particular column names or schema will be utilized in order to do the analysis onto this particular file, right? So this is the detail or this is the value. Now you are performing like you are doubling the values, you are tripling the values, so depends upon the logic that you are going to write. But the thing is that you're going to create a structure onto top of this, and that will be say spark data frame or pyspark data frame or pandas data frame. Okay, or in another words, once we are talking about databases, that will be the different like the columnar structure that we have given to this particular file, or what we have created onto top of this particular file, right? Right, Vandana, is it fine?
Yes, sir. Yes, sir, it is
Okay,
fine.
Shivam, Swati, Rohit, any confusion, any doubts of
No issue.
No, sir, clear.
It's fine.
perfect, huh? So what we have seen data lake, data warehouse, and database. These three terms we have seen, we have gone through in detail. Now another fancy term like delta lake. So delta lake, what is the meaning of delta lake? So data lake, what it is saying, this is not acid compliant. Not no acid compliant. Acid compliant. Acid compliant is what over here? The database is acid compliant. Acid compliant, that is atomicity, consistency, integrity, and durability. These are the four characteristics which are you can say solved by databases. Now databases are acid compliant, and because of that we are able to use it in OLTP related operations. OLTP, online transaction processing. Okay, so acid compliant. Now people are thinking like data lake, that is fine. It is used for raw data management, but can we put some acid compliant onto top of this? So then certain research, whatever like delta lake and lake house, these are the new emerging architectures which are there inside the market. And what we are doing over here, what we are able to see, like acid compliant with data lake, so what is say, it brings acid compliance with with data lake. Okay, so it is Delta Lake is going to bring acid compliance with Data Lake. And once we are having something that is acid compliant, then what we can say, that is going to be used with OLTP related operations. Yes, Vandana or Swati, who was saying, who was speaking?
I'm sorry, sir. I was answering to somebody else at home. Sorry.
Okay, not an issue. So, the concept is quite straightforward once we are talking about Delta Lake. That is the combination of acid compliance with data lake. And you are having the understanding, if something is acid compliant, that it can be used for the OLTP related stuff. The latency will be minimized at that moment. So low latency. Another stuff, what is given, data versioning. Okay, so data versioning, what is happening? Each write create a new version. Okay, so once we are going to write the data, so at each and every moment, it is going to create a new version, and with the help of that, like versioning is maintained, and we will be able to track the changes. So that is the beauty which is given by the delta lake, and the major aspect from the delta lake what we are able to see that it brings asset compliant with data lake, and you know it very well. If like something is asset compliant, then atomicity, durability, consistency, durability, integrity, all of these particular things will be there, and then it can be utilized for the OLTP related operations. So that is something like a little bit introduction from the about the delta lakes. Then what we are having lake house. Okay, so lake house, another you can say delta lake, that is the combination of acid compliance with data lake. And once we are talking about lake house, that is what? That is the combination of data lake plus data warehouse. So it combines or combination of data lake plus data warehouse. Okay, so it is going to provide like combination of best features from data lake and data warehouse. It is going to provide best features from both of these two. Okay, warehouse. Okay, so what are the best practices or best features which we are able to get from the data warehouse or data lake? So data lake, what we are able to get from the data lake, that is we are going to maintain the raw data inside the data lake. What we are having raw data. Okay, it is used in ELT related operations. So what, in another words, what I can say, data lake, this is not utilized for the processing perspective. Data lake was not having the processing capabilities, but over here in this particular emerging architecture, what I can say, combination of best features from data lake and data warehouse, that is we are going to integrate processing capabilities on data lake. Data lakes were not having the processing capabilities. Try to focus over here. Data lakes are not having processing capabilities. What I have mentioned in these particular components, database, data warehouse, data lake, and lake house, data lake is the single component which is not having the processing capabilities. All of these are able to do the analysis on top of your data. But inside the lake house, what I can say, we are going to attach processing capabilities on data lake, so we will be having the unified solution in order to perform storage and processing. Okay, if someone is asking I need to store the data, raw data, then you will have lake house. If someone is saying like I need to do the processing and analysis as well, then you can provide the lake house. Okay, so lake house is the combination of best features among these two tools, data lake and data warehouse. So what I can say, attaching processing capabilities on data warehouse or data lake. Then it can be utilized for batch processing and streaming processing, or you can support batch processing, batch and stream processing. Okay, this will be the cost effective solution. Why cost effective solution? What I have mentioned, this is having least cost. Data warehouse is having somehow more cost than data lake, and database are very costly component. But as we are attaching processing capabilities on data lake only, so this is the cost effective solution. That will be the cost effective solution. Then it will be able to store structured and unstructured, and unstructured data. Okay. So you will be able to handle structured and unstructured data over here, and cost effective solution can be used for batch processing and streaming processing. This is the scalable solution. Okay, because this is built on top of data lake only. And what we can say, we are having unified solution for processing and data storage. Okay, that is lake house. So in short, what I can say, database is something which is dealing with structured data only. Data warehouse, that is also dealing with structured data, and it is good for ETL related stuff and having the processing capability. Database is also having processing capabilities and ACID compliant as well. The data lake, that is dealing with raw data only. It is not having processing capabilities, and it can store structured and unstructured data. Okay, we can have data in different formats over here, and if you want to read the data from which is stored inside the data lake, then you need to define the schema. So schema on read over here. Once we are talking about delta lake is nothing but we are adding ACID compliant onto data lake. So data lake, once we are having data lake as ACID compliant, then we can say that is delta lake only. And it is used for OLTP related operations like transaction related stuff. We can utilize it, and it is having low latency, fast processing will be there. One major benefit which is given by Delta Lake, that is it is going to maintain the data versioning, and at each and every moment you are going to write the data, it is going to create a new version, and then you will be able to track the changes. Once we are talking about lake house, that is the combination of data lake and data warehouse. So data lake is having the best feature. It is going to maintain the raw data, and it is very cost effective solution. Data warehouse, we are able to process the data. So once we add these two best features from data lake and data warehouse, then lake house will come into the picture, and these that is the emerging architecture. And over here, like that will be the cost effective solution. Over what I mentioned, you will be able to handle structured and unstructured data, and it can be a unified solution for data processing and data storage. Okay, so these are, you can say, the differences between database, data warehouse, data lake, and lake house. Okay, now we will move with our topic. What we have started, that is the redshift, and what we have seen with respect to the redshift, that is a cloud based data warehouse, and it is able to query petabyte scale of data and fully managed service from the AWS side, and this is really very fast and scalable. And why it is so much famous?
One
Because
query.
it is, yes.
So can we say data lake is having ELT operation, that it also go for extract, load, and then transform, just like your data lake?
Database.
Delta lake is having the same property as that of your data lake. That is your ELT.
Okay, try to think over here. So we are performing ETL operations, ETL or ELT operations. Why? Like we are fetching the data, we are ingesting the data from a particular data source and then putting inside a data storage. Data storage can be anything. Now it will depends upon your use case. Okay, it will depends upon your use case, and majorly we are going to perform the ETL related operations. ETL, because like we are transforming the data first and then loading it so that the upcoming operations will be very less. We- uh, will be Upcoming operations will be onto less amount of data, right? So what is the benefit? Say if you are going to perform ELT operations, ELT, even like ELT operations. So if you are performing ELT operations, you are extracting from here, then loading it. Okay. So majorly ELT operation that will be done with data lake only. Okay. Because we are loading the raw data and then performing the transformation. Okay. So if you want to do this particular stuff with data warehouse as well, you can do over there, but that is not the preferred way, right? You are like moving the data on a particular location. Okay, if you are moving the raw data or you have transformed the data and then loading it, it will depends on you. So you can either load the raw data, but this ELT is less preferred because we want to work, we need to perform the operations. Say we are getting certain data after ETL or ELT stuff. Now what we need to do on to top of that particular data, again we need to perform apply certain formula, we need to apply machine learning algorithm and all, then we will be
So
having the
I'm asking for
outcome.
delta lake, not data warehouse. Like your
Hmm.
delta lake is a combination of data lake and your data warehouse, right? So is
Uh-huh.
delta lake working on your what do you say, ELT or ETL? That I'm asking.
That's what I have explained. It is not like say you can leverage ETL. You just need to leverage ELT or ETL. You can choose anyone. Okay, you can choose
इंदु
anyone.
ने
In
कल हेड बात
like
लिया ना, या फिर पता नहीं कब मैंने अपनी रिंग खोली और रखी और अब पता नहीं वो कहाँ है। मैंने
okay, Vandana, Vandana. Yes. So what I was explaining, you can use any tool for ELT or ETL related stuff. It is not like say ELT is meant for data lake only. Okay, you can utilize it in data warehouse or database as well, but that is not the preferred way. Okay, we are going to maintain the raw data over here. Okay, like if we are having lake somewhere, wherever we are able to see lake, so we can maintain the raw data over there. Okay, over here we can maintain the raw data, over here we can maintain the raw data, over here we can maintain the raw data, we can leverage ELT over here. Okay, we can leverage ELT, but the best way, try to use ETL stuff, like extract the data, transform it and load it, so that you will be working with less amount of data, and you will be able to boost in the performance. Over here you are extracting, loading the entire data, and then transforming it, and then performing the upcoming operations. So that will delay your performance, that will degrade your performance, the outcome will be delayed over here, right?
Okay, sir. Clear. Thank you.
Okay, so you can leverage any methodology over here in order to process, but the preferred one is ATL. Okay, so Redshift, that is a data warehouse. So with the help of Redshift, we will be writing SQL-like queries over here, right? SQL, SQL-like queries to analyze your data. Then what we are doing over here, it is going to provide you uh, performance, 3x performance with respect to other cloud data warehouse services. This is the best one. This is the best data warehouse service among other cloud services, data warehouse services. And you will get the insight of data in seconds. So these are certain things with respect to the Redshift, that is the petabyte scale data warehouse service. And if you want to like query petabyte of data, you can be able to do it in seconds with the help of it. Now the architecture of this Redshift. Architecture of Redshift. So what I have mentioned, this is master and slave architecture what we are having. Okay, just have a look over here. This is master and slave architecture. Okay, so inside the Redshift, what we are having, we are having like a slave machine. We are having multiple slave machines and a master machine. Master is nothing but the leader node over here, and the slave machines are known as compute nodes, huh? So slave machines are compute nodes. What we are having over here, just have a look. The help of you will be able to get the understanding in a good way. So leader node and the compute node. The compute node is further divided into node slices. Node slices. Just try to think the Spark architecture. What we have seen over there, like we were having different worker nodes, like worker node one, worker node two, worker node three, and inside the worker nodes, what we are going to do, we are going to create different executors, huh? Executors, what are the executors? That is the combination of processing capabilities and storage, huh? Or memory, what I can say. So in the same fashion, what we are having over here in Redshift, that is the master and slave architecture, that is having multiple slave nodes known as compute node, and compute node further divided in terms of containers known as node slices. Node slices are nothing but certain processing capabilities with memory, and because of this, it is going to provide massive parallel processing related stuff, MPP. Okay, so if we are having a task onto the leader node, what the leader node is going to do, it is going to divide that particular task among the compute node, and compute node further divide that particular task into the node slices. Okay, node slices which are going to process your data. Okay, now coming back to the leader node, that is the master node, master node, and from the master node, what we are able to see, JDBC and ODBC connectivity, and the certain client applications are sitting onto top of this, so this particular leader node is going to act as a mediator or as a bridge between the client services and the cluster, the Redshift cluster. If someone needs to interact with the Redshift cluster, he is going to connect with the leader node and saying, "Hey, leader node, I just want to perform the execution of this particular application. Then please try to do the execution and provide me the output." So the leader node is going to take that particular application from the client, and it is connecting with Java database or open database connectivity, and then with the help of these particular connectivity modules, these particular applications will be able to interact, and data processing is done with the help of compute nodes, and you will be able to get the outcome. So this is the architecture of Redshift. What is happening over here? These are the actual execution machines which are like processing onto top of your data, and the leader node is going to maintain or lead all of, or going to provide or distribute the tasks among these particular compute nodes, and then you will be able to get the outcome, so that is something with respect to the architecture of this particular Redshift, over here what we are able to see, the detailed architecture, now what we are able to see over here, we are having this Redshift cluster, and Redshift cluster, what is happening over here? So this is going to say, what we can have the data onto the S3 or on a particular, you can say, a database, and from that particular database or data lake, what we can do, we can store, we can move the data inside the Redshift cluster. Okay, and once we are having the data inside the Redshift cluster, then what we can do, the Redshift is going to process onto top of that particular data, and we are having certain services where like we can apply machine learning algorithms, that is we can leverage, we can integrate uh, different services like Amazon SageMaker. What we can do, so the data which is placed inside the Redshift cluster, we can apply machine learning algorithms onto top of that particular data, or you can like move that particular data, or you can ingest certain like data from some operational databases, move it inside the Redshift once the data is very huge, and then processing can be done over there. Over here, like these are certain, you can say, applications from or connectivity modules from which the client machines are going to interact with Amazon Redshift. Okay, it might be serverless or provisioned. So the Redshift service is serverless. That is the new stuff which is there inside the cloud environment. Previously, like we just need to create a cluster, but now Redshift serverless is also available. We just need to configure one service. It is going to, or we just need to have certain steps, and the cluster will be triggered. The cluster uh, will be created based upon your query only. There is no need to create a front cluster. Okay, and then proceed for the operations, the stuff what we have done in glue. For the glue we have not created any cluster, for the Athena we have not created any cluster. So same stuff is possible with Redshift serverless as well, or we can create the cluster as well for Redshift. We will see how to create the Redshift cluster, and we will see like how we can move with the serverless as well. So serverless, that is the new concept, but we can create a cluster. So this is nothing but the Redshift cluster what we are having over here, leader node and the different compute node over here. These are the connectivity related stuff. With the help of that, the clients are communicating with the Redshift cluster. Over here, we are having certain data sources from where like the data is moved inside the Redshift cluster and it will be processed. Over here, what you are able to see, Redshift managed storage. If Redshift is serverless, then certain storage is managed for this. So that is the storage layer over here. And then the compute. So compute acceleration and compute, that is like like whatever the data that you are getting, so it will be processed and then it will be shared, and we will be having the Amazon Redshift spectrum as well, that we will see. So it will be sitting like this. Okay, so say we are having Redshift data warehouse, we are having S3. We will cover in detail as well, but I'm just providing you an overview. So we are having Redshift data warehouse that you are able to see over here. Okay, Redshift data warehouse. So data warehouse or data storage basically. So we are having Redshift data warehouse, or you can say this is the entire Redshift cluster, and we are having S3 location, that is data lake. Now we are having certain data over here and certain data over here, and we just want like we don't want to move the data directly as from S3 to Redshift. So what you can do, you can leverage the Amazon Redshift, and what it is going to do, without moving the data from S3 to Redshift, you will be able to use Amazon Redshift that will query the data on S3 only. So no movement of data will happen over there, because the data movement from S3 to Redshift cluster will take some time, and that particular time will be minimized over here. So redshift spectrum is used in order to add the performance where the data from the S3 is not moved to redshift cluster, and you will be able to get the outcome. It is going to query exabyte of data. Once the data is placed inside the redshift uh, data warehouse, then you will be able to query petabyte of data, petabyte, exabyte. It might be possible like you need to perform the join with the data which is placed over here and with the data which is placed over here. That is also quite possible. You just leverage the redshift spectrum. So these particular things are shown over here. Okay, so you can take the data, okay, and you can accelerate, you can compute, and then you can visualize it onto, you can integrate it with third party tools in order to have the visualization and all. So that is the detailed architecture what we are able to see over here. So that's all about the redshift architecture. Just have a look and ask if you are having any doubt. Redshift architecture. Is there any doubt on redshift architecture? Rahul, Vandana, Shivam, Swati, Rohit.
No, so clear for me.
Others, Vandana, Shivam, Rohit.
No, sure, it's okay.
Okay, so that is like certain inputs with respect to the Redshift uh, architecture. Now, over here, what we are going to see, say services, inside the services, what we just need to pick, we just need to pick the Amazon Redshift, that is a service. And over here what we are able to see, Amazon Redshift fully fast, fully managed petabyte scale cloud data warehouse. That's what we have like gone through with our definition, official definition, like that is of, that is able to scale petabyte scale cloud data warehouse. And it is fully managed service from the AWS side. What we are able to see over here, try Redshift serverless free trial. So this is the new service what I have already mentioned, and this serverless customer receive $300 credit to use in their account. So if you are going to use serverless Redshift, then you will be getting $300. Probably like this service is not being utilized. Because of that, it is offering certain discount. Okay, as this is the new service and the Amazon is like trying to promote this particular service. Now another stuff what we are able to see, like getting started, Redshift serverless, evaluation and POC support. So if you want to get certain help, so from that particular documentation you will be able to get certain help. Now for more granular control, create cluster. So if you want to create the cluster of your own, what I have mentioned, so it is Redshift serverless or provisioned. So if you are moving with serverless, you just need to click over here. And if you want to provision your cluster, then you need to click over here. Then certain stuff what you are able to see over here, benefits, get insights from the data in seconds, save cost and stay on budget, experience consistency, high performance, get started with no modifications. Okay, and related services, there's no need to use cases. self service analytics, auto scaling, like we just need to enable this and it will be going to scale up and down automatically, huh? So there is no need to bother about the scaling related stuff, huh? So that is like an overview with respect to this redshift, and today we are going to see how to create the cluster, huh? So let me click on to the create cluster. Okay, and the same like the promotion you are getting over here, if you want to uh, like go with the redshift serverless, you will be getting $300 credit in your account, huh? Then the cluster configuration, cluster identifier, you just need to provide a cluster name. Okay, choose the size of the cluster. Now over here we are having uh, two types of resources, huh? Okay, so I will choose, or like help me to choose. So inside this particular redshift we are having two types of resources: dense compute and dense storage, huh? So RA3 recommended, or DC2. DC is dense compute and RA is dense storage type, huh? Like say managed storage up to 4 terabyte, 4 TB. Okay, managed storage up to 120. So these are the dense storage resources what you are able to see. Okay, just have a look. Manage storage up to 4 TB, and dense compute over here the storage is less, huh? Like say storage 160 GB per node, storage 2.6 TB per node, huh? Okay, so let me select say this one DC. I'm just going to have the list resources. I just want to have 160 GB per node and two vCPUs, Gen 2 second generation. Now over here it is asking like how many nodes you want to have inside the cluster, huh? So based upon the selection, say if I'm going to have two nodes, it is going to provide me the cost. What will be the cost for first like 1 month, huh? So it is saying say $365 per month, huh? That is the cost, huh? And if you want to save, like it is going to provide certain recommendation as well, huh? As DC2 was having 160 GB per node, so in total you will be having 320 GB space onto the inside the cluster, huh? Let me pick one node and it is going to divide it, by two. So 182.5 per month and 160 GB is the space that will be available, huh? Now it is saying say sample data. If you want to have sample data, if you want to have some like we are having ticket data is there, that is the sample data. I'm having that particular data as well. Let me show you. Okay, so you can, if you want to load this particular data, you can check it. Redshift. Okay, so ticket DB I have already downloaded. So if you want this particular data be available in your cluster, okay, so just click it. Then database configuration, admin username say AWS user, manage uh, admin credentials in AWS secret manager. Okay, so you can check this, or you can generate a password. Okay, click this one, and then IAM role, you need to define IAM role. So associate IAM role. So I'm having certain IAM roles which I have already created. So let me pick this big data factory redshift, associate my IAM role that has been associated, and okay, let me create the cluster, okay. So in this particular way, I will be able to have the cluster. It is in creating state. Okay. Soon it will be created, and once the cluster up and running, then I will be able to perform the operations, and what are the different set of operation that we are going to perform. So we will be moving with this particular example, like we are going to have these particular, we will be moving with these particular stuff, create a sample cluster, configure inbound rules and all, then we will provide the access, load the data example, and reset the environment. These particular things we will see in our, yes, tomorrow's session. Okay, so I just want to give you a flavor like how you will be able to create a cluster, and how you will be able to, what are the different things which are available onto the AWS console. So the cluster is being created. Soon it will be way up and running. Then you will be having that particular cluster, and you will be able to query on that particular cluster. So Redshift, that is the data warehouse, and it is master and slave architecture. Once we are going to select, create the cluster, it is asking for the nodes. Either we are moving with dense compute or a dense storage. So based upon our use case, we just need to provide the required number of nodes. Once we are working with the serverless, then like different things will come into the picture. Okay, so this particular service from the AWS side can be serverless or on the provision one. At this moment, we are moving with the provision one. We are like going to create a cluster with one node that is having two vCPUs and 160 GB storage, and and uh, okay. So master node, that is the leader node, and the slave nodes are nothing but the compute nodes. So it is providing massive parallel processing, and why massive parallel processing? Because the parallelism is happening at multiple levels. So first, the task what you are going to have, that will be distributed among the compute node, and the compute nodes further divide that particular task into the node slices, which are having the processing capability, which are like in actual going to process your data. So those are the node slices. So that is with respect to the architecture. So it is modifying. Soon it will be up and running. So we will be going to create all of these particular tables and all, like create tables. Then after creating tables, we will be moving the data from S3 to the cluster. Okay, and then we will be trying to query onto those particular tables what we are going to create over here. So these are the straightforward commands what we are going to copy and paste, and then we will be able to do the analysis of our data. Okay, I just want to show you like the cluster up and running. So this is an overview of our cluster. Okay, so the cluster identifier, this is the name of the cluster. Over here we will be able to see the status, the node type, number of nodes. Okay, the cluster namespace ARN that will be utilized into the query and all. Okay, endpoints, these are the endpoints, like Java database connectivity URL or open database connectivity URL, in order to connect with this particular cluster, and then we will be able to perform the queries and all. We will see. Okay, just I want to show. Okay, so storage used and all. Soon it will be up and running. Modifying, it is in modifying state. What has happened? I think data is not loaded properly. Okay, so manual snapshot cluster, this one. This is in modifying states. And these are the visualization related, like monitoring related things from the cluster side. What is the CPU utilization, percentage disk used, space used, then auto vacuum space, database connections. Okay, health status, query duration, each and everything, like monitoring related stuff from the cluster side. Query monitoring, zero ETL integration, okay, resource policy. Over here we are able to see V2, query editor V2. So once we are going to open query editor V2, we will be able to see the different things, like how to query onto the data. Like we will be able to see querying mechanism where we will be able to write our queries. Just have a look. Mhm. It's taking time. Okay, so this is Redshift query editor. Okay, you will be able to write your queries. You will be able to create your tables over here. The cluster is, I think, not up and running. The cluster is up and running now, na? The cluster is up and running, and then like this inside this particular cluster, we are going to perform our operations. So we will be going to create certain tables, and then we will be able to query the data. We will be able to perform joining and all. We will be going to see how to do the partitioning and all. So different things we are going to perform inside this particular cluster. So what we have seen in our today's session, we have gone through with like the basic introduction about the Redshift and the differences between data warehouse, database, data lake, delta lake, and lake house. So this is the stuff, and at the end what we have seen, like how to create a particular cluster. The cluster is up and running. Over here what we can do, we can resize it. Like if you want to increase or decrease the number of node, you can reboot it, you can pause it, and you can delete it as well, huh? You just need to delete. Okay, the cluster will be deleted, huh? Okay, so, so let me pause it first. Pause now. You can't pause Redshift cluster because no recent backup was found. Create a manual snapshot or wait for the automated snapshot, then retry. I don't want to create a snapshot. Okay, so it will be deleted. So the status came to modifying, and it will be deleted. So this is the stuff what we have seen in our today's session. Let me stop recording and take your queries.